Welcome to the presentation of a geotechnical investigation pre-feasibility report for the construction of a substation out in the city of Tshwane, Gauteng area. Vikesh Rampasa Consulting was appointed to undertake the geotechnical desktop study for the proposed development. The development is of compact class and complexity is standard. The scope of the development ranges all the way from power transformers all the way to steel structures and foundations. The scope of this feasibility report is to analyze existing geotechnical information to identify the geology at site, all the way through to identify possible problem soils, recommending mitigations, and then all the way to provide conclusions and recommendations. The information sources we use were geotechnical maps, as well as reports on the geology of the area, seismic hazard identification map, and the Google Earth satellite imagery. There's a picture of the locality plan. The site is located in the city of Tshwane in a low valley area called Moot. It is bordered by Magaliesburg to the north and Brandberg to the south. Those are the site coordinates. Um, Accessibility to the site, there are no formal roads which border it. It's accessed by dirt roads. This is the Google Earth video showing the site out in the Pretoria area, city of Tshwane area, Gauteng province. Shows the Magaliesberg and Brandberge to the north and south. And as we zoom in further, we'll see the access to the site, which is via dirt roads, which are parallel to the R104. Also out on the site, we will see that the vegetation is of veldgrass type with some shrubs and trees. Trees in the on the site in the northeastern and south. I mean northwestern and north and southwestern areas. The drainage of the south is northeast to southwest at 3%, which is 2 degrees. The climate is it's classified as subhumid. It's temperate interior, and its mean annual precipitation is 650 to 740 moles. Mean maximum and minimum temperatures are 24.1 and 12.2 degrees Celsius. It's in a Wynard area with it's in an area with a Wynard N value between 2 and 5, which is 2.5. That means chemical weathering is dominant. There's the area and there's a proposed site. Topography and drainage out of the site is that the site rises, as we said, northeast to southwest at 2 degrees. The site is considered flat, and drainage will be via surface water across the site. Vegetation, as previously mentioned, the seismic zoning is that it's not in a seismic hazard zone and is not underlined by dolomitic rock. Look at the geology of the site. The geology of the site is that it's got Silverton Formation as the bedrock, and it's included by a diabasal in the upper quarter of the site. There's an extract of the map showing the proposed site, Silverton Formation, and the diabasal intrusions in the upper quarter of the site. The residual soil from these rocks is a clay type soil, and then the transported soil will be a fine colluvium due to the positional environment of the site, as well as the Magaliesberg to the north and Sheetwash across the site. That is the conceptual geotechnical soil profiles for the Silverton formation, as well as the diabasal intrusion formation. Problem soils, we expect clay to be out on site according to the geotechnical series map. Mitigation measures are as listed here, with stiffened raft foundations the probable course of action. Anticipated excavation conditions, according to map, moderate excavation problems, back active may be required, no lateral seepage due to low permeability of the soil, excavation of sidewalls, we assume it to be stable due to cohesive material, and then additionally no groundwater seepage because of a low water table and no aquifers. Construction materials possible around the site from quarries as listed here. And then on site we can maybe source the clay for maybe construction of a berm and to the retention pond, and well as residuum soil and shale can be processed for layworks. Proposal of field works is test holes 30 each, as well as DCP testing 30 each again, and also field identifications as desiccation, cracks, and erosional gullies should be observed. That's a proposed setting out of the testing. Laboratory tests, we reckon 5 per soil profile, typical 2 soil files, therefore 10 of each of these tests, all the way from gradient analysis all the way to the California Bay relation. These are material classification tests. Further to this, we recommend material characterization tests, which is soil pressure testing, and again 10 in total. Stormwater management will be via roads, an open channel. This will actually drain into a retention pond that will be constructed in the southwestern corner of the site. Health and safety, relevant legislation is the Occupational Health and Safety Act, construction regulations, and then the COIDA Act also. It's a quick run through of the process, which will be undertaken to ensure compliance, which starts with appointment, uh, to preparing a health and safety plan by the contractor, then to discussions and negotiations all the way through to regular audits and handing overs of the health and safety file on completion. Relevant environmental relevant legislation is the NEMA Act, Environmental Impact Assessment Regulations, listing notices. And again, there's an overview of the processes that will need to be taken from appointment all the way to receiving authorization and monthly audits. Listing notices that triggers this is that it's a development for the transmission of distribution of electricity and the clearance of indigenous vegetation. This all requires environmental authorization. Conclusions, we move on to Silverton Formation. Rocks are intruded by diabase sill in the upper court of the site. Weathers to a residuum with rock fragments, residual soil above that, transported soil collovium above that. The loading is estimated to be less than 20 kilometers per meter. The expected bearing capacity of residuums and residual soils is greater than this. Therefore, the site is suitable for the proposed development. Moving on to recommendations, the raw foundation we recommend with an integrally cast floor slab and reinforced plinth. Thus, the underlying soil should be rubbed to a depth of about 600 millimeters and it should be recompacted in 2 times 300 millimeter layers uh, for both the foundation construction and cut for construction. After this report, the feasibility phase of the geotechnical investigation must follow. The proposed tests are as in sections 5 and 6 of the full report, and the depth of investigation we recommend 1.5 for this development. There's a list of the references that we've used to compile our full report. The full report is available from Vickers Rapids Consulting at this address and at that contact number. Thank you very much.